Hi everyone, welcome back to the course. And let me first share my screen here. Okay, share. Okay. Okay, in the last class, I believe we stopped where we stopped here. So we mentioned the concept of function. Basically, the reason we want a function is because we want to make things, like some repeated things easier. It's kind of like a package. It will be something similar, like we will mention in today's class later as a class. Okay, so I believe I run this example last time. And now let's have a look at this one, the gas number. So let me first Python. Let me build a new project here. New project. Let me call it in class again, and this in lecture 3. Yes, great. Okay, here we go. And what's the name of this one? Let me create a main here. Okay, recall we actually mentioned this example. Where it is? Lecture 3. Anyway, not big. Let me give me 1 second. Let me I want to make it here.
I got a quick question, if you don't mind.
Yes.
Is there any specific reason why you're using PyCharm versus Jupyter Notebook or Jupyter Lab?
No, that's a very, very good question. Actually, in the next lecture, I will use Jupyter Notebook. You're absolutely correct. The reason here I'm using PyCharm is because note that here technically I'm teaching the Python in general. You know what I mean? So Jupyter Notebook is super convenient for running things like, because it uses the cells, things like data analytics. But here, technically, I'm teaching Python in general. So I would prefer PyCharm because PyCharm, it is going to be more general. Let's say if you run some project, then maybe you're going to prefer PyCharm than Jupyter Notebook, because if some big projects, basically PyCharm is way more powerful. So that's the main reason. But you're absolutely correct. Later for like linear regression, for many things, I would say not all, many things will run it in Jupyter Notebook, which is exactly in lecture 4 actually. Thank you.
Got it. Thank you.
Yeah. Sorry, because just now I had 2 lectures, so here because I just renamed everything. Sorry about this. So let me have the things here, make it to be main. Okay, so and then remember regarding this example, we actually ran it in lecture 2. I believe lecture 2.6 or something, or 2.7 maybe. Exercise 2.6 or 2.7. Let me see. Guess a number 2. Yeah, here we go. Exercise 2.6. And I believe I finally fixed the code because last time something was wrong with the code. Okay, so I can simply so this one is the lecture 2. No, let me this should be lecture 3 here. And we can actually modify this code to be what? To be a function. So we need to define what? We need to define 2 variables, which is secret number and also the max gas, right? So we can define, let's say, gas number. Let me have a look at it just in case. 3 times, it's gonna ask you whether it's correct or not. If it's correct, then correct. Otherwise, game over. Okay. So we can define, let's say, secret number and also maximum gas. Okay, so these 2 things become variables. And the chance equal to this one can be put here. And don't forget one extremely important. What happened? Looks like I pressed something wrongly. Okay, don't forget an extremely important thing, which is the column here. And also remember, all indents are must. You must have the indent. So it's not like C or Java, something you use, big bracket, here, no indents. Okay, so let's have a look at here. So basically I have this one, which is which is the maximum gas, and then this is this. So this I is the number of gases actually, while it's less than the maximum number. If it is equal to, then you nail to break. If you fail, if it's wrong, you guess the wrong number, then the guess number +1 and the chance number -1. And finally, if let's say maximum numbers reach, then game over. Okay, now we can actually run this. Let's say the guess number. Let's say suppose the secret number is, for example, 8. Suppose the maximum guess, for example, is how many I said here? I forgot. So 3, 2. Okay, let me run 8, 2. It doesn't matter. Okay, then let's run the code. So it will ask you, okay, guess the number. Or actually, correct number is 8, right? So let's suppose I don't know. Let's say I guess of 2, 5. Okay, wrong. One chance left. Let's say I make a 1. Okay, game over. And then I can run it again. Suppose again the first time I choose to be 3. Wrong. Sorry. And the second number is, suppose I make it the correct number 8. Okay, you nailed it. So here we go. You see what I mean? So the thing is what the thing is here, I can actually make it to be a function. And good thing is every time I can run different number, let's say 3, 3. I don't have to every time kind of rewrite, or go to, the code line by line to change. I just need to make all these kind of numbers. It's very simple. Let's say 1, 2, 3, you nail it. So this is an example of this is lecture number 2. I can close it. This is an example of how to use the function. I believe, yes, here we go. Similarly, why close it? I should not have closed it. Similarly, this is the next example. We can also write it to be a function. So the next example here, for a number list, write a code to find a small. Wait. Let me see. I think duplicate removal. It's not. It's this one, exercise 2.8. So we can copy and paste here. To looks like I didn't write the 2.8 here, but it doesn't matter. We can rewrite it. It's pretty simple actually. Let me just by chance, did I get it in main? This main is not that main. Okay, it's not, but not a big deal. We can just rewrite it. So basically, you will be asked something, and then you will have write everything again, right? Okay, so we can just, let's say, define, let's say, duplicate removal. So we just need one thing, which is the list, right? So which is your input list, and then I will have an output list, which is everything new. And we are gonna create a new list called unique. And then we just for let's say element, or let's say for x, it doesn't matter what is in list. So if this x is not in unique, then what's gonna happen is I'm gonna append this x. If it is there, then do nothing. That's it. So finally, I can just return unique. So this is the thing. So we can definitely do. Actually, let me do this. Let me print unique, and then return unique, so I don't have to put a print here. So let's run. Let's say duplicate removal. Let's say, let me just randomly give a 1, 2, 2, 2, 5, 4, 1, 5, 5, 6, 7. Let's see what's gonna happen if I run it. Okay, indeed, you see it. All these duplicated numbers, 5, 5, 1 here, are all gone, and only the unique numbers are left. So this is the thing. Remember before in lecture 2, how did we do it? We do it like this way. So they're basically the same thing. However, I need to put every time if I run different things. First of all, I need to go back to such a long code. Second, I need to find this specific line, which is the input list, and I change it. It's easy to make a mistake because in a real project the total of the lines could be millions. I'm really no kidding. I mean, and then it's gonna compose of maybe hundreds or thousands of those kind of small let's say functions, codes, packages, something like that. So the idea of function basically is that I just let you modify something which I let you modify, or something to make a life more efficient. For example, here, list is allowed to modify. It's not like here. What if, let's say, you make a mistake. Let's say instead of making a change in list, you make a change in unique, then everything's gonna be wrong. You know what I mean? So this is the another example of the function. Let's do some exercises here. Write a function to input a numerical list and find the minimum number. So, well, it should be super simple. I don't know why I showed both, but here, I mean, in the class, to save some time, I will only show the for loop, which is super simple. Let me see whether it's my lecture 3. Okay, so let me create one. Exercise 3.1. Okay, so I want to find the minimum, right? Define, let's say, find minimum. Let's say list. Be careful here. We define this list to be a numerical list. So what can we do here? One of the one of the simplest thing is to use the main function. You can just return, let's say main list. Done. Then but I know this is not a point. Just to let you know, print main list. Okay, done. So when I define, I just realize I find the main. Let's say I just I just random define a function. Let's say 1 5 -1 4 for example, and then I run it. -1 done. But this is not a point. Okay, assuming that I don't know the main function, right? And so I have, oh, yeah, no, I need to know the index as well. Find numerical, let's say find the minimum number, both the value in the index. So whenever I see the index, you want to think what the index, method, right? And the index method to find the first index that equals to this number, but it doesn't matter because if we have several, we just need to show the first. So we definitely, the idea is this, suppose we have different numbers. Let's say I have this list, right? So I will first let the min to be the first number. And then I will go to the second number to see whether the second number is big as mean. So whether the second number is smaller than my recorded mean. If it's smaller, then I will have the recorded mean to be the second number. Otherwise, continue. And then until the end of the loop, then I will already go through all the numbers, and for sure I will record the mean. Okay, so let me directly write a thing like this. So mean value equals to, let's say, list 0. This means I will put the first number inside and also the list of the same mean index equal to 0. Okay, now what's gonna happen is that I'm gonna make a for let's say number in, let's say, list. So I will go through it, right? If number actually I use a while will be more efficient. I don't, not big deal because I already make, so I can, if I use a while, I can start from I equal to 1 instead of I equal to 0. But I mean, not big number, not a big deal. Since I use for, I just use for. Let's for number is less than mean value. So if it is less than mean value, what's gonna happen? So I'm gonna have set this number to be the mean value equal to number, and also don't forget index, main index equals to list the index and the number. So because currently I am in this number, so this is to find the first one. There's no problem at all. And then finally, I'm gonna return the main value, main index and main value. Come on. And main index. So here we go. And then you can just simply run this. And then let me see. Let me just make the print function here as well to make my life easier. Print main value equals to main value. Main index equals to main index. Okay, here we go. And you can see indeed main value is -1, main index is 2. Again, be careful. The first element is the index is 0, not 1. Okay, 0, 1, 2. And you can do whatever you want. For example, you put it here, it doesn't matter. It's gonna be -1. So here we go. So but this is, you know, the function itself is extremely simple. What I want to show is how to make it in the function, you know, and you can think how to use a while loop as well. So while in this specific case, actually while should be better because, you know, you can directly set I equal to 1 because you don't have to run the index 0 again. But I mean, this is some very small things, not a big deal. Okay, so please check the while loop by yourself. And then after in general function, I would like to introduce an extremely important function for people, for lazy people like me. So lambda function is basically a super small and a quick anonymous special function. So you don't have to like remember to define a function. We say, oh, define function name, variable name, blah, 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 return something, right? Lambda is extremely simple, just lambda arguments expression done. So let me show you an example here. So for example, lambda, I define x equal to lambda a. A is plus 1. That means what? That means, okay, a is a variable or an argument, and then I'm going to return a plus 1. Done. You know, so you can simply just, you know, go to, let's say, print x1, x2, something like this. Let me just here, let me go to the main thing to return, let's say x equal to lambda, let's say, what's the function? I forgot again, sorry about it. A plus 1. A plus 1. You don't have to use A. If you want, you can use Z. I mean, these are not big deal. The big deal is that it defines something called X. So X is defined by Z plus 1, where Z is a variable. So you can print, for example, X1, let's say X, let's say 10, whatever things. You can see X1 is 2. X10 is 11. See it? If we don't want to write in this way, what shall we do? We need to write like this way. Define, let's say x function, let's say z, and then return z plus 1, something like that, right? But here you can see use lambda is super simple and fast. This is sometimes, you know, in my code, I need a very small part of like a function, so I can use lambda function. And I believe, yeah, here another example, I can define 3 arguments A, B, C. So it's going to be a squared plus 2b plus c. So you can clearly see x1, 2, 3 means what? 1 squared plus 2 times 2 plus 3. So it's clearly 8. So this is a function. Let me show you a real example, 2 examples of using lambda, which is extremely efficient and but important. The first thing is called a filter function, and the second one is called a sorted function. So as the name, filter to filter, sorted to sort. Let's have a look at the filter first. So filter is something to filter the target, for example, a list based on the function and keep the result that satisfies the condition defined by the function. So I believe it's better you know, to have something like this. So here lambda numbers is a list. So this list is first of all numerical. Second, then I try to filter what? I'll try to filter the target is let me see, the target is numbers. As you can see here, numbers is my target, but the function is the lambda function, which is lambda x. X is not equal to 2. What does that mean? That means I will filter the function, you know, kind of like x is not equal to 2 out, and then keep the results. In other words, as long as I have something 2 here, everything will be gone. Let's run this example. Let's say numbers, let's say equal to whatever. It's gonna filter 2, right? So let me put like 2, 2, 2, 2, 2, 2, let's say 5, 3, next 2, 2, 2, 3, 2, 2, 2, 2, okay, to whatever. So I'm gonna say number filtered to be, let's say, first of all, I need to make it to be a list, because otherwise it will be something can see like this way. Suppose I don't have it to see what's gonna happen. Filter. Let's say here I need to have a lambda function. First, why? Because here the syntax is first of all is a function, then is a target. So I'm gonna say lambda x is not equal to 2. Okay. And then the second part is what? Here the function, the second part is target. The target is simple, it's just numbers, which is this list. Okay, so if that's the case, let me print. You will probably see something interesting. Here we go. See it? Filter object. Because this is filter is going to return to an object instead of some numbers that we human can understand. So here we'll, oh, sorry, we'll need a list so that to let Python know, hey, transfer the filter object to be a list so that we can directly read. And here we go. Indeed, you can see all these twos are gone. You see it? There's no two. Two is not two. Next two is also not two. So that is how we can do here. I believe the second is something to filter an odd number or an even number here. Okay, the second example here, everything the same, but here I change to be lambda x. X module, this module operator 2 is equal to 1. That means what? That means filter all those kind of or I should use that term keep. Let's say keep all odd number. Only odd numbers will be kept. Like here, only numbers not equal to 2 will be kept. If equal to 2, then 2 will be gone. Similar here, only numbers modular 2 equal to 1, which means it's an odd number, it will be kept. So let's do it. So let me, unfortunately, I don't have too many odd number. Let me add some negative 9, let's say negative 9, something like that. Okay, so here I'm going to do what? Modular 2 equals to 1 numbers. And then let's run it. And indeed, you see all these numbers to make a good habit. You may want to, put a format like this, put a blank between after the comma. And you can see all these kind of even numbers are filtered out. See it? Only odd numbers are kept. Here we go. So this is the filter function. You can see the power of lambda. It's so simple here and all done. Otherwise, you will need to write, several lines of the codes. It's or like if you don't use a filter, you're going to write a for blah 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 blah. It will be kind of like pretty troublesome. But here, just lambda plus filter, all done. Nice. Well, the next example would be sorted. Sorted by the name, it's just very simple like a sort function. In many cases, you will use the filter and or sort function. For example, if you have a database or something, here suppose I don't know what is SQL or something. Let's say suppose I just brute and suppose I don't know any SQL circle. Let's say SQL3 this kind of libraries. I just want to brutally let's say run a Python and run this kind of database. Then you're gonna see lambda. Sorry, filter and the sorted function are something you are gonna use every day, and lambda function is absolutely your first choice. Why? Because it's efficient. So sorted, it's similar to filter. I will have the target and then the key, and then the third keyword is called reverse. So reverse is basically, the sort like direction. It's going to be ascendingly or kind of like reverse means descendingly. And the key is again the function. Here you know that we're going to use a lambda function. Target is just a target. So let's see an example here. So example here, I have 3 authors. And then I want to sort them by -1. That means the last name. So for example, I write a name in this example like this way on purpose because I want to use strip to filter those kind of blanks and also title to make it the title format. And then I just sort it authors. This is again target function reverse true or not. So authors is here. Key is this lambda function. And by default, the tar reverse is false. In other words, it's going to sort ascendingly. So here, key equal to lambda names dot split -1. Think about it. Why do I need to dot split -1? What if I don't need it? Okay, let me just run it, but I need to remember Albert Einstein, Carl Gauss, and Leonard Euler. Okay, let me just use here I have forget again names. Authors are called okay. Authors equal to I can run them add something. Let's say bird. Let's say Ains. Let's say Kane. Second one is Carl Gauss. No, I remember I had a Friedrich Gauss. Okay, I cannot remember his middle name. By the way, Carl Gauss is really too smart. I mean, many of his papers, even we learned today is amazingly nice. And the third one is they are not Euler. How do you spell again? Forgot. Doesn't matter. Okay, so the first thing we're gonna do is what? What should we do? We should first of all make all the names to have a good format, right? So we're gonna say for name in let's say here let me see. I probably cannot write for naming authors. Let me see. If I write this way, it will be, let me see. No, I cannot, because if I write in this way, it will be copied to another another. So basically what we can do is this. Let's say new author. Let me create a new authors here. So this is another method. Let me create an empty list called new authors dot append, which is authors. No. Name dot strip dot title. Here we go. So this is one method. So that I will do like a sort function based on the new authors. So this is method number one. So I can just just make a comment again, control plus the backslash. Method number two is I will need to use the kind of like the while loop, or sorry. I will use a while loop, or I can use something like for, let's say, I in range length of authors. But what I'm gonna do is authors I. So in this case, I don't have to use another space. I will directly operate in the original list. Authors I dot strip. Oh, sorry. Dot title. So in this case, what I'm gonna have is print authors. In this case, I should have already, okay, here we go, the same thing. Authors have already been, have the correct format. The problem is that what I need is not only the format, I want to sort it, right? Okay, so now I will have this sort. Authors sorted equal to sorted. And then first is the target, second one is the key equal to let me see, lambda. I need a, let's say, give me 1 second. Okay, here we go. So we have the authors, right? Let me call it all. Let me call it ABC. It doesn't matter. So here ABC means what? Means ABC is a variable in the lambda, but this ABC is actually this authors, just to let you know. So I will have ABC dot spelled -1. What does it mean? So this means, okay, if you give me this target authors, I will have so authors now looks like this, right? So I will spell it by this one, by the space. And then -1 means what? The last one, which means the last name. In other words, here, what I mean is that, okay, you get Einstein, you get Gauss, you get Euler, and you sort them. Get a point? Again, here key, this lambda function means for the target, I'm gonna get the last name, and then I will sort by the last name. And then you here we assuming it's gonna be kind of like ascending, so that you even don't need to do anything, because by what? By default, the reverse is false. Reverse is, you can write the reverse is false as well, which means we don't have to reverse, which means ascending. Yeah, we can never run like this one. Okay, now let's run it. What's wrong? Oh, okay, sorry. It should be author sorting, not authors. Here we go. So you see it? So Einstein is E, Euler is U, is also E, and then Gauss go to the last. You see what I mean? So it's already sorted. Remember, I'd better print authors first, and then print authors sorted. So this is our original one. Gauss is the second one, but now I also sorted become the last one. Or if you would like to have the all other, which is true. So in this case, it will be the opposite, which is descending. So it will be like this way. And you can see Gauss is the first, Euler the second, Einstein the third. So this is a sorted function. And you can see the power. I mean, if you if you want to brutally code it by yourself, it's gonna really take some time, because here sort function, and also because we here's the last name, we can use some pretty simple tricks, I believe. It could be n log n the complexity. It should be pretty simple because totally only 26 alphabets, and we know the range. But here, we can use a Python provided sorted function plus a lambda, so everything is gonna be pretty easy. Any questions here? No? Okay. Yeah, I believe this is pretty straightforward. And next one is something like the data. Let's say suppose later we'll mention the class, but suppose here you just consider it as a list instead of a human or something. Actually, it's kind of like a list of human. That's a student 1, 21-year-old male, student 2, 19-year-old female. So what I'm gonna do is that I wanna have everything sorted by X1 first, which is the gender first, then score second. How to do it? Similarly, you can use this sorted plus lambda function, but your lambda function gonna be like this way, x1, x0. This tells the sorted function that, okay, I will sort based on x1, which is the gender, the last, the second one. Let me call it the first element, which is the gender first, then x0, the second gender, the age second. And you can see the result indeed like this. So maybe I should just run it. It's pretty simple. So I have, let's say, students equals to let me just ignore the age. Let's see. Okay, age and the gender. Let's say male. Let's say I just randomly, put a number. Okay, I just because I cannot remember. 18. Let's say female. Oh, sorry. Let's say let's make another one. Let's say 16. That's a male. Okay, now let's make something like this way. And then I'm gonna sort based on what? Based on the function. So I will have the student, oh, sorry, student sorted to be the sorted. Again, students is my target and the key equal to lambda. Let's say I believe I use x, but here is just x1, x0. So you're supposed to have many. Let's say you have another, let's say, course. For example, okay, let's say course, let's say calc, whatever. Say. So you can always use this one to make which is the first order, second or third order. But here make my life easier. I just consider I only have two. And then I can simply print student sorted. Student sorted. Here we go. Here we go. And so you can see female, male. See it? And then in terms of female, 18 first, then 22. In terms of male, 16 first, 21. Why? Because by default, our what? Our here reverse equal to true. You know what I mean? For false, sorry, which means it's ascending. And that's why for a small number to big number, and indeed f is, alphabetic order, f is before n. If I use true, then it's gonna be the opposite. Here we go, male first and the big number, big age first. So this is another thing. And indeed, I mean, this is super powerful. Looks super simple, but it's really powerful. The code is very efficient. So this is the main thing that I want to mention about function. Actually, function itself has many interesting things, like for example, like recursive function and many different structures. But here, due to time limit, I don't have the time. If you're interested, please just you can search, go to YouTube, search Python functions, the tricks or something, and there are many projects for the functions. So I will go to the next one, which is called a class or classes here. What does a class mean? A class in Python, actually in any coding language almost, modern coding language, is the blueprint of an object. Remember, Python is an object-based, language, and hence, as an object, I can have something like a methods, attributes, something like this. And what we have already mentioned before are all actually those kind of like string classes, list classes, and they do have those kind of methods like upper, lower, title, blah blah blah, and also like methods for list like index, count, appendix, which are all in lecture number 2. And I can, as I mentioned, I can use type before, to show what is that. And you can see here I define a string. I like Python, and the list I like, like I like Python, and then I see the type of it, and you can see class string, class list. These are all the things. I believe we've already shown everything, in lecture 2. So we can actually define our own classes. And indeed, a question is, why do I need a class? I mean, I just define like what I did before. Everything's good. Why do I need a class? Again, it's the same reason as why do I need a function, which is, oh, sorry about it, which is I can make things like easier, compact, and it can greatly avoid mistakes. So for example, we can define here, we can define students, let's say John and Mary. I'd better give me a second. How can I can define students from John and Mary, and I can have attributes, let's say name, age, grade. So I can simply just define a class named a student, and then I can define 3 attributes, name, age, and grade. And then every time I need a new student, I just have define, define something as a student class, as a student class. And then I can have something, let's say John as a student, Mary as a student. Finally, let's say Ewan as a student, Jennifer as a student, Harry as a student. Everything just so I don't have to every time I rewrite everything like name, age, grade, name, everything again and again. You know what I mean? So it will make things very, very efficient. And another reason is because Python is an object-oriented programming language. Making a class, I create an object. Everything is going to be much, much easier. Again, class is the blueprint. Okay, now let's see some simple, let's see some simple examples. The very, very first thing for the class is the initial function. Underline initial. This is a special function in Python. This shows that when I define a class, this is the initial things. So here we have self. I mean self and self. It is always there. You can just at the current stage you can ignore what does self mean, but it just means the class itself. So I will have 3 inputs: input name, input age, and input grade. And then I can define 3 attributes, which is the name of the class, the age of, the name of the object, student object, the age of the student object, the grade of student object. Then I create the detailed instances. Let's say Ewan is a student. So I can define this way, student, and then it's gonna ask you, hey, what are the 3 variables or arguments, which are the name, age, and grade. So I can put it like this way. I guess I'd better directly write it here. So I'm gonna define a class called students. And then define initial function. Okay, now I will have something else. Something else, which is the name first, age, and then grade. And then, so I will immediately have self. Again, self means the object itself, the class. I should not say the class, I should say the object of the class. The name equal to name. Be careful here. This name means this name, but this name is an attribute. That's the reason why here in my slides, I make it to be input name to make, a difference to be, this input name is an input argument or input variable means it's here, but this name is actually an attribute, okay? But here, because I'm lazy, I just directly name, but be careful, what does the name mean? This name is this name, but it's not this name. This name is an attribute. Self dot age equal to age, and then self dot grade equal to grade. Okay, here we go. So now I can define, let's say students. For example, I can have Harry equals to, okay, students. So again, 3 attributes: name, age, grade. So Harry age, let's say 13, grade, let's say 80. By the way, you don't have to write Harry here. The reason I write Harry here is because this student names is Harry. So for my memory, for ease of my memory, I write Harry. You can write AB, whatever, let's say ABC. You know what I mean? So, but I would prefer using name. Otherwise, who knows who's who, And again, so you can see here, Harry is what is an object defined in the class named students. And then every time, say I have another student, let's say John equal to students. Again, you know what I mean? I can have John. Oh, sorry. Age, let's say 18, let's say score, let's say 78. I can just, define a lot of students. I don't have to, otherwise I need to write every time like Harry does something, like repeat those kind of things again. I say Harry, age is 13, grade is 80, John again. But here, I pack everything in one. I just need to define the student. Everything is done. You see what I mean? Isn't it actually the same as a function, but it's kind of like a higher level function. But now I can just simply print, let's say, Harry, oh, sorry. Harry dot, let's say name, Harry dot age, and, oh, sorry. And Harry dot, let's grade. Here we go. What the hell, the keyboard. Okay. And you can see indeed Harry, the name is Harry, age is 13, and grade is 80. Isn't it the same as what you make? And we can do whatever. Suppose you have a lot of students, so we can just, make everything. So this is the meaning of a class. So, okay, so here we introduce the initial function here. And here we're gonna say that, wow, in this class, you can define functions as what we did before. So remember here, we define student, should be students instead of student, because it's a list, not a big deal. It's just a name. You can even call the student ABC, whatever. And then I can define two functions which introduce, which is my name is what and I'm several years years old, and I can say get a curved grade. I know for many students this is a favorite thing, curved grade. So one very traditional curved grade algorithm is the grade square root of grade times the 100. Say you have 100, so square root of 100 is 10. 10 times 10, you still get 100, right? But if here you are 36, your grade, the square root of 36 is 6. 6 times 10 is 60. In other words, as long as you get a 36, in terms of this curved grade, you are qualified. I mean, you will pass the course. So this is curved grade. So we can define these two functions here. So for example, I can just define, introduce, oops. What is that? I forgot, sorry. Print. My name is self.name. Yeah. And I am self.age years old. Immediately here question, why do you need to write self.name instead of, because here I already input a name. Let's say I put input name, right? So can I just make here to be input name? Can I do it? Oh, sorry, wait, is there something wrong? Here's wrong. Suppose, everything like this way. Can I do something like this way? In this specific example, yes, you can, no problem at all, because we've already seen self.name equal to input name, so they're the same. However, later we'll introduce that we can define some function to input this attribute. Don't forget that dot name is an attribute. So what if I already, let's say for example, grade, let's say originally the student's grade is 80, for example, and then I use some function to change the grade, set grade equal to 90. So you always want to get its newest grade instead of the original grade, right? And hence you use self.grade. It will be way better than you directly, you say, I'm lazy, I just want to put a grade. It's gonna be super simple, easy to make a mistake. So always try to use the attribute instead of directly put the direct argument, unless you are 100% sure that this will never be changed. But I would highly recommend you always only use the attributes. It's gonna be a very good habit. Here, let me just self.name. Okay, here we go. Oh, one more thing here, name. Okay. And then another thing is the curved grade. Define curved grade. So you're gonna return what? Let me say self dot, the same reason here. You need to use self dot grade instead of grade. And then square root of 2. And then times 10. So, okay, so here are the things. So once we have all these, what shall we do? We just need to, we can do something. Let's say, first of all, I can say Harry dot introduce. Why? Because Harry is an object or an instance of the class students. And each, object, I do have a function called introduce. So I can say dot introduce. So it's gonna print, hey, my name is Harry, and I am how many years old? 13-year-old. Let's run it. Okay, run it. My name is Harry, and I'm 13-year-old. And then I can print Harry's name, Harry's age, Harry's grade, and also I can print Harry's dot curved grade. So Harry's grade is 80, right? So Harry's curved grade will be what? Will be 89. So basically, it's gonna be like this way. You will have wait, let me have the scientific. You will have square root of 80. Oh wait, how to make it? Square root of 80 equal to 80 square root maybe times 10. So 89.44 something. You see the same number here. So that's the thing. Here we've showed, in the class, define initial function and then define some function that I would like. I believe the next slide I will define a function to change something. Here's something, as I just mentioned, the grade. I can set the grade, you know what I mean? And that's the reason why here you'd better use self.grade instead of the grade, because I can always change the grade. Like here, I can define function, let me see what I do here. Set grade and set age. So, okay, I will have, let's say, set grade. Instead of function, I will say a new grade. So what's gonna happen here is that self.grade attributes equal to the new grade. You see what I mean? And similar, I can define set age, self and new age. Oh, sorry. Okay, anyway, let me define set age, new age, why? Age here. And then self.age equal to new age. Here we go. Then suppose here I have a Harry. Again, I use instead of Harry.introduce, I can have Harry.setAge to be, let's say, 14. And I can use Harry.setGrade to be, let's say, after 1 year, Harry Potter's score is higher. Now he got 85-year-old. Oh, sorry, he's 14-year-old and got the new score is 85. Now let me print everything again, and you will see. See it? New age is 14, new score is 85, and the new cover score, again, 85 square root times 10, which is this one. You see what I mean? And hence, if here you use my age as age instead of self.age, it will be immediately wrong because you will be reading the older data, while here I have already updated Harry's new data. You see what I mean? So here's the thing, that you can always change the attribute, within a function defined inside the class. And here is something, this way is, this thing is very important, that I can define two classes. And the very, very interesting thing here is that the argument in the method of a class can be an instance of another class. So let's see what happens here. So first of all, I define a class student, and then I define a course. The course is a course name maximum students. And let me see here. Okay, course name maximum students, and I have the name is the name and the maximum students. Why don't I just simply do it here? Sorry, here I cannot remember so many codes, so please allow me to take the cheat sheet here. Okay, to save my life, let me just remove everything here. Actually, it doesn't matter. All of them can be just still kept here. I need to define a new class. Sorry. Let me define a new class called course. Let me use courses as well. I have the course name and the maximum number of students here. And then I will have self the name equal to the name. Be careful, this name is the course name, not the student's name, okay? And then self dot maximum maximum student equal to maximum students. And then another thing is self. So here's the trick. In this class course, I define a new attribute called student. And initially, I put this student, thing to be empty, an empty list. Students, sorry. But basically, I would like to store the students who register for this course, you know what I mean? And also, as we have already defined class students, so you know what? An object of the class students here can be a variable, and can be kind of like a variable or something like a method here. And again, I can define, as here I showed, I define another function called define add students, add a student, okay, self and a student. Be careful here. This student here is exactly would be the student, I defined here. But first of all, I need to make sure that the total number of students is, not more than that. If the length of self dot students, so basically I want to see, hey, totally, what is the length of my students here? This can show how many students have already registered for the course, right? If this one is less than self dot maximum students, that means yes, I can add it. So I can say self dot students dot append student. And this student is this student. And then I can print, here I directly return, but I can print one thing. Let's say student, let's say put sorry, F student is successfully added. But what if I also return true? What if it's not? In other words, I've already reached my maximum number of allowed students here. I'm gonna first print the course is full, has reached the maximum registration number. Student is not registered. There we go. And then return false. So we can do it like this way. Okay, now let's check this again. So first of all, I define I can ignore John. Sorry, John. Let's say I can have no, I still need it. I have Harry. I have, let's say, John. Let me define another one. Let's say myself equal to students. Let's say Ewan, and then let's say 20. Okay, I wish I'm 20 years old. Suppose I have 90. The grade is 90. Okay, now let me have the course. Let's say ML equal to courses. Why? Oh, I define the courses like this way. Okay, so I need to use capital C courses. First of all, I have what? The name, which is machine learning. Second, and maximum students. Let me temporarily put the maximum students to is 2 here. Now, okay, I have ML dot add student. So here, remember, add students is what? You need to, self you can ignore, but you need to have a student here. You know what I mean? So I already have created 3 students, Harry, John, and Ewan. So I can add students inside. Let's say I add Harry inside. And then I dot add student. I can add John inside. And finally, I try to add myself inside. Okay. Then let's see what's going to happen. So here, let's suppose we don't need this. Let me just comment it. Okay. Now I want to print course dot student courses. Sorry. Courses dot students. Dot. Did I define student or students? I forgot. Courses dot students. Yes. I should use ML. Sorry, my fault. ML dot students 0 because I'm just copying here. Dot name. ML dot students 0 dot age. ML dot students 0 dot grade. Guess what's going to happen? First of all, by adding students, I will add either successful or fail, right? But be careful here. The maximum students is set to be 2. However, I try to abruptly, add 3. What's going to happen first is it's going to tell you the first 2 are. Oh, what's going to happen is here's an error. No append. No append. How come no append? Where it is? Self dot students. Let me see what is wrong here. If length is smaller than this one, then the students dot not maximum students, sorry about students. Students, yeah. So the students is right here, this attribute, not this attribute. Here we go. Okay, excuse me. So let's see, let me make it bigger. So let's see. So first of all, let me see, student. Here we go. Student dot name. The reason is because student here is also, the variable here I want to input is actually a class. So for example, Harry dot name is Harry. Here we go. So student dot name is successfully added will be Harry and John. Why? Because the maximum number of students allowed to register for the course is set machine learning where it is 2. Then when I try to add the third student, Ewan, to the course, it will say course has reached maximum registration. And then again, forget student name and here student name as well. And then so student Ewan is not registered. So this is the thing. And then finally we'll print ML student 0 name, and the first student whom is Harry, age 13, grade 80. You see what I mean? And then go back to our slides. You'll see the point here. The argument in the method of a class can be an instance of another class. You see the point here? So here, student is actually an instance of another class called a student. Here in my code, I call it students. There's an S here, but not a big deal. So these are the things. Be very careful of this. So with the class structure, we can actually define those things pretty easily, and we can cross-use these instances. Here's an example. So basically, I want to define a class called people with input name, and then define, the thing is to get the first name, get the last name, and get a middle name to make it this way. Be very careful of one thing, that some people can have a very long middle name. You know what I mean? In other words, middle name, or some people like me, I don't have a middle name. So you need to kind of like judge whether the length of the name, if you split by, the blank is more than 2. If it's more than 2, then the person must have the middle name. But anyway, we can just simply code it. What's the name of this exercise 3.2? We can just say here new Exercise 3.2. Okay, so here we need to define a class called people, right? So let's first define a class people and always initial. And then we need what? We need a full name. Okay, now what we're gonna do is we'll make full name kind of like a relatively good format. That's always what we do before. Full name equal to full name dot strip dot title. So in this case, we will we'll make the full name kind of like ignore all the blanks before and after, and also make the title format. And then we need to do what? The three names, right? First name, middle name, and then last name. Let's do the first and last name first because that's always easy. Get first name, let's say. Okay. How do you get a first name? Simple. We have already had the full name, and we already have make it like a beautiful format. What we need to do is what? Is to make the name to be to kind of split them into a list and get a first, cell. Sorry, get a first string. So we can directly return self dot full name dot split. So let me make an example here. Let's say E1 equal to, let's say, people. I just randomly, let's say this is my last name. Okay. Then what's gonna happen? I'm gonna print first name. Got first name. See it? See what's gonna happen that first of all, this one will make it to maybe I can you don't have to just because I want to show step by step here. So first of all, it will make the name to be this way. And second, to split is to make it to be uh so this step by step. First of all, make my input name as a wrong format. I can make it like this way, it doesn't matter. It will be all the same to be like this one. And then second split to split into a list, with I will differentiate by the blank, and then so first name, last name. You see what I mean? First name is simple, you just get the first element, first name. And the get the last name is exactly the same actually. You just need to what? You just need to put split instead of one, you just get net one. So this is the last name. I can just add here last name. Oh no, get the last name last. Get last name. Okay, so here we go. First name this one, last name is you. But the problem is how to get a middle name. For example, like myself, I don't have the middle name. Or you can, let's say, suppose XX. I just randomly write something. Let's say let's say AAA is the last name, right? So can I write simply like this way? Define get middle name. Wait, could be like this one. The keyboard. Can I just return, let's say, to one? It's not necessarily correct. Why? Because of course, in this specific instance, looks like middle name. And this specific name, in specific case looks as correct, right? But don't forget, what if I don't have this? Suppose I'm like this one. I don't have my last name, my middle name, you see? And it will read my last name as my middle name. Or suppose I have many middle names. So I want to show your middle name is AABBCCC, but if you're making this way, it will only keep you the AA. You see what I mean? And hence, this is not a correct solution. So first of all, we need to actually, you know what, to differentiate whether that person really have the middle name or not. To this end, what I can do is, let's say, I first to split the name, let's say, split to be let's say self dot full name dot spelled. Again, I need to use the blank to be the what. Okay, now I've already remember. So now I already have this, right? So I can judge directly test the length. So if the length of the name split is greater than 2, so I know, yes, the person does have this last name, middle name. If it doesn't, then directly return no, which is the easiest to say. Done. Okay. Now suppose the person name is greater than 2. I need to consider how to add all of them instead of just have, the first middle name, right? So I just need to write something, write kind of like a while loop or for loop, so to, have append everything, then it's going to be done, right? Or you can just use add, it doesn't matter. Let me see, what did I use here? Okay, I use a okay. I use a plus instead of append. So I can have, let's say, mid name equal to name split 1. Why? Because I know it's greater than 2 already. So at least it has one middle name for sure. I know it. And then I directly can set up I equal to 2. This I is actually nothing but the index, meaning that from which number I will start. So I already, suppose in this case, I already put AAA to be the middle name. So I will start from here, 0, 1, 2, BBB. So I will say while I is less than or equal to length of name split plus 1. Wait, not -1. Let me see. That is -2. Sorry about it. It should be -2. Why? Because -1 will be the last thing. Remember, our last index number is always the length -1. And then I actually should stop here instead of here. And hence -1, -1, hence -2. While this is less than or equal to -2, what's going to happen is that mid name equal to mid name plus, let me give it a blank, and then plus name split I. In other words, what I'm gonna do is that I already have a middle name equal to AAA, and then I will have start from, this thing, I will AA plus BBB, and then plus CCC, you know what I mean? And I will end in CCC. And here we go. And by this one, I should have the middle name. And finally, don't forget, I plus equal to 1, which means to move the index. Here we go. And now let's just test this one. How come? Middle name is now. Great. No. This is correct. Let me see why the middle name is. Let me see here. Length greater than 2. Yes. Middle. You know what? Super stupid thing. I forgot I forgot to write the return. That's why. Return middle name. Here we go. So now it should be correct. Okay, here we go. So you can see, even if I put this kind of weird name, it will correctly recognize first name is E1, middle name is AAA, BBB, CCC, and last name is U. You can test some real name. Some people's name is very, very long, and but here I make a fake middle, but basically the idea is the same. I put a Carl Gauss fake name. You can, if you have a friend or yourself, the name is pretty long, which means you have several middle names. You can use this function to test. So this overcomes the issue that's, middle name more than one, word. Okay, so this is another the exercise 3.2. Next thing is the static variable for a class. So what is a static variable? Static variable by the name static means it's just static. It's a shared by all instances in the, let me put it here, by all instances in the class. It belongs to the class instead of to the student. So for example here, we have a number of students equal to 0. This is a static variable. While this name, age, these attributes all belong to the instance. So for example, here I have E1 is this one. So I define the student name is E1, the name is 20, and this 20 belongs to this instance. And this name also belongs to this instance. The same here, Jennifer, that's an 18-year-old Jennifer, the name, everything belongs to the instance. However, this variable, number of students, this variable, you know what, belongs to the class, students class itself. And now I can say print number student dot number of students. Be very, very careful. It's not even dot number of students or Jennifer dot students, but the student, the class dot number of students. Again, static variable belongs to the class. Okay, now I can see 2. Why? Because I have this line, which is every time whenever I include a new instance, then the number of student dot number of students will plus 1. You see what I mean? And this is the point of number of students. And the next thing is class method. I will go through the part here very fast because class method will not be applied in this class. I mean, although in some bigger projects you will use a lot for the class method, similar to the static variable, class method is a method for the class, and the syntax is at class method. So we can see again, suppose I have a students variable, a number of two static variables, number of students, total age. Then I want to actually somewhat calculate. You know, here I define a class method which is define get average student get average student age. So what I'm gonna do is that the here CLS is kind of like the self. It's again just kind of like it's self means the class student itself. So I have CLS dot total age, which is here, divided by CLS dot number of students. So every time when I have a new instance of student, I will have the student dot number of students plus 1, plus equal to 1, and the age plus equal to age. So this will calculate the total number of age of students. And here, this will calculate the total number of students in this class. And hence, the total age divided by the total number of students equals to what? Equal to the average. Here we go. You see what I mean? So the point here is to show the class method, which is get. Again, no matter static variable or class method, both of them belong to the class instead of an instance. So this is a very, very different thing from all the class variables, class functions that I introduced before. And also here, class inheritance is something similar, which is the class name and the parent's name. Let me see, I don't believe we will use it as well. So for all this, I'll go very fast instead of running the codes. If you're interested, I would highly recommend you run the codes, in your own ID. And again, you don't really have to use PyCharm. You can definitely use Jupyter Notebook or whatever you want. It's really not a big deal. So here it is. Suppose I have 2 classes and I have a child class name, and I can inherit all methods attributes from the parent class. From here, I define a class called pet, and I have the pet name, pet age, pet has a function introduced, my name is blah, blah, blah. And then I have a class called a dog. And you can see if I write in this way, dog, and in the parentheses, I write pet. What does that mean? That means dog is a child class of the pet. Okay, and then I can define a function called bark. So whoa, that's dog. And I define another class called cat. So initial something here, super initial, that means I inherit everything from my parent class, which is pet. So everything, you don't have to write everything again. Everything's gonna exactly be the same like here. This is the meaning of soup. And then here I define a new attribute called color of cat. Be careful, cat has the color, dog doesn't have color. I didn't define the color here, okay? And then for cat, I define a new function called a meow. So here I print a meow meow, and also you can see here, I didn't define introduce it, but because my cat class directly is a kind of like a child class of pet, and hence I can directly use the function introduced from pet. I directly inherit, that's the meaning inheritance. I directly inherit everything from my parent's class, which is pet. Hence, I can directly say, okay, cat dot introduce self. So it's gonna say, for a cat or whatever, my name is blah blah blah, and then here print, and I am color, because color function, color attribute only belongs to cat. Okay, now I'm gonna create instances of the classes. First of all, I create an instance dog called autumn. The name, the age is 15 years old. And then I can print dog.name, dog.age. You will see autumn 15. Then I'm gonna use the dog's function, which is bark, dog1.bark. So it's gonna say vol. And then I create another cat instance, which is called cat's name is Maria, age is 2, yellow, color, name, age, color is yellow. And then I print cat1.meow. And you see it's gonna say first say meow meow, and then cat.introduce, which is here. My name is Maria, and print fprint, and I am yellow. Here we go. You see what I mean? So in other words, sometimes if I have many classes, and if we have some, some we can make some structures like I have a fundamental class and then many subclasses. So I can write in this way, which is I don't have to define. Suppose I have many functions here. I don't have to write everything again and again. I can just use this inheritance to make the classes, the structure of the classes, so it can make my life easier. So this is the meaning of the inheritance of the classes. Okay, so this is everything about the classes. Any questions? I remember many of you are like professional, like software or computer engineers. I believe this is you have used this classes, thousands of times. This is really too important. Why? Because in the real case, let's say project, in most cases, you will not be the only person to code let's say a software or the whole project. You will have, let's say, a lot of people, let's say, suppose 10 people in the group to finish this project. So what we're gonna do is that we will all have those some packages. You write a package, I write a package, John write a package, and then we will have our different definitions of the things. Let's say in your package, I means something, and in my package, I means another thing. If we put everything together, it will be a big chaos. And hence we can have the packages, which the next thing import I'm gonna say. And then in the package, in different packages, we can have this kind of classes. So this will make it, the code more robust. It's not that easy for us to make mistakes. Otherwise, if we make everything all together without any classes, any functions, it will be a big mess, and it's too easy to make mistakes. So that's the key reason for using functions and classes. Any questions here about the functions and classes? No. Okay. The next one is something pretty simple. Here, to make it relatively complete, I know in my slides I wrote a lot of things here, about the module something, but here I just introduced something what really be used in this later in the data mining, in the machine learning class. So here we are going to import something as something. So the thing we're going to use the most is this. Let me show you. Import numpy as MP. Here we go. Import numpy as MP. So numpy is kind of like a library, as NP is a short name. So later I can use NP dot something. And all these things are, the function something defined in numpy. But it's a bit, let me go back here, sorry about here. Okay, so import something as short name. This as short name is optional. You don't have to. You can just use import XX. Or you can say from XX import ZZZ. This means ZZZ is a special function or variable classes, because import XX, my XXX can have a lot of things. But in my main function, I may just need several small, simple things. So I don't have to import all of them to save my time, the time of running Python. So I can use this. Let me show you, and also modules are something like, give me 1 second, syntax. Modules are some structures, and basically we have, sorry about it, let me go here, module, package, library, and the framework. So framework is the biggest one, collection of libraries. Library is a collection of packages. Packages is a collection of modules, and modules is basically, basically those kind of functions. If you can consider all those things as modules, or you can create something here. I will have a slide, after it. But let's have a quick look at import modules here first. So suppose I have two .py files here. Module 1 is here. So you can see I define square function, square root function, student class. Module 2 is here. Sorry, module 2 is here. I define exponential function and another variable called g. Okay, now I can say import. So the file name module 1 is to be imported 1. File name module 2 is to be imported module 2. Both are py, files. So I said .py. So import to be imported 1, to be imported 2. And you can see what I can directly use, let's say student. I need to write to be imported 1 dot student even, you know what I mean? So I will have to here because I only have one attribute, which is the name or here. And then I can say s dot introduce. Why? Because s is a instance of the student class here in module 1. So I can say import this and then s equal to the name here dot student and then something blah blah. And also similarly, I can go to module 2, which is to be imported 2 dot exp33. And I can even write to be imported 2 dot g. But don't you feel something dangerous here? Why? Because here's a g variable. What if in your main code you also have a g variable? And accidentally, if you write like to be important to like this way, so this will immediately cover your G. You know what I mean? You need to be very, very careful so that you need to write to be imported G. So here's the thing. And to be honest, in most cases, it's highly not recommended to import a variable because there could be too easy to make a mistakes, could really destroy your whole project. So again, in most cases, do not import variables directly like this. Okay, so but here is the thing, and you can see that the name is pretty long. To be imported 1, to be imported 2, blah blah. I can make it shorter, like what I wrote here as a short name. So I can say that this to be imported this one as TT1, TI1, and to be as TI2. So I don't have to write a long name. I can use everything replaced by TI1, TI2. So this is the thing. And the third thing is, as I mentioned here, I don't have to import everything. I can from blah 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 import only a specific, functions or kind of specific groups of a group of functions or classes. Here we go. Here from here I import square root and a student. Here I still keep the second one as TT2. So the difference is that here, because from here I import here, I can directly write student square. You see what I mean? By comparison here, you need to write ti1 dot student, ti1 dot square. Here I don't need. I can directly use square. So I can directly use student, use square root. And by comparison here, ti2, I still need to write ti2 dot something, ti2 dot something. So this is the difference, from of these two syntaxes. Import something, add something, and from something, from something, import functions or import, let's say, classes, something like this way. Okay. And then there are some Python built-in modules, and we can see here. Give me 1 second. Allow. So this is because here I believe my Python the version is 3.12.3. So these are the things, and you can see all these are kind of like already included modules here, and you can directly use them. So let me show an example here. Import math. So after get import math, so we can directly, and you don't need to say from somewhere import something because this is already there. I mean, from Python. So you can say import math dot square root of 9. So the square root of 9, clearly it's a 3. Dot ceiling function, floor function, log function, sine, cosine, tangent, arcsine, arctangent, all these things are there. And if you want to have a full document of everything, here we go. You just need to upload here math. Here's math. So you can just click it and you will see everything here. This will be the same. This is going to be the same as this one. You can see it. So version different. Here's the whole Python 3, but here's Python 3.12. I mean, not a big deal. For fundamental usage, it's really not a big deal. So everything's the documentations are here. So and also I showed an example as a random, as we can see the random here, randoms here. So by the name randoms to generate some random variables. So you can have let's say ignore seed. So I can have the random like ignore range and my favorite is this random int, so integer. So I can get a random integer which is between less than or equal to a and greater than or equal to a, less than or equal to b. So that's the thing. So I can use this one, and I can also let's say random get random bits, and I remember I also show the random range as well, which is that's a print random, which is just a number, and then print rand int, which is generate a random number between 1 and 10, including numbers 1 and 10. So it gets 3. And finally, this is actually a normal variate. You will run this a lot, in later in this class, but that's not under the random variable. The random package will use a NumPy. Okay, but another library, but the functions are basically the same. Another thing I want to mention is random.choice. This is extremely useful because instead of, for example, here I can set up a list called students, including 3 students. Here, random.choice student means you choose just one of them. And then you will see it. Choose the person to be monitor and print monitor. And then finally printed the middle one, Jennifer, to be monitor. And if you're familiar with functions, it's actually nothing but a random int, isn't it? The variable is going to be between 0 and the length of the list minus 1. So in other words, you just randomly choose an index and then print out the corresponding string. Done. So this is the meaning of random choice. But I mean, it's just simple. You don't have to write a function again by yourself. So these are some examples of the Python, internal included modules, math, random things. Again, we will in this course we'll later use all NumPy, another library. And here, let me see, what do I do? Write a function to input a number n and then flip n dices, print all of their points and find the largest. This is so cute. Okay, so let me just write it. It's just actually super simple. Okay, so I need to flip in dices and then print out all the largest number. Okay. What's the number? 3. New Python. So I need to import random. Why? Because to flip a dice, in order to run a simulation of flipping a dice, I need to generate a random number between 0 and 6, right? So I can say define flip dice and then n. This n means how many times you want to flip a dice. So I need to have 2 things. First thing is to record all the points here, right? Points equal to, and the second thing is I need to guess the maximum or minimum for that. Let me see. For the largest one. Okay, so I need to get the points and also I need to get a maximum, right? Maximum point equal to, let me make it to be -1 because basically I just need to a fundamental number, an original number which will not be equal to 1, 2, 3, 4, 5, 6, and also the maximum. Let's say let me put a dice here. So this will tell me which one is I should have it. Yeah, I do have it here. I have the maximum dice here. Tell me which dice is the maximum. So I can say, now I'm gonna flip these n dices. So I can say for I in range n, and then I'm gonna say, let's say point p equal to, let's say random dot rand int 1, 6. This means what? This means generate a random integer in 1, 6. And because we're running dice, a dice has 6 sides, 1, 2, 6. And then I can what? I will have the points dot append p. This means I will add a result into this point function, into this pointer list. And then I'm gonna do what? I can just let's say print it. Let's say dice I, which give me a P here. Okay, let me run it just in case. Flip dice, that's a 2. Sorry. Should be I plus 1 because my I range starts from 0. So, I should be I plus 1. So now it's okay. So this means I flip the dice for twice and both of them get 4. That's interesting. Okay, here I run the dice for 2 dices. The numbers are 2 and 4. Okay, now I've already generated all the dices, but the thing is I need to get the maximum, right? Yes, maximum. The maximum point. And also I need to know which dice is the maximum one, right? So how do you do it? So what I'm going to do is the same. Remember, we just finished a code, which is find the maximum. That one find the minimum, right? You can use the minimum, but here, instead of using the mean, well, if I use the mean, then I will, well, if I use the mean, then I will have the thing here, like a mean, points. I will make something point. I will make something like this way. But again, instead of writing this one, points as the function here, instead of writing this one, let me just directly brutally make it. So exactly the same idea. If the first dice, if the current dice number is bigger than your recorded maximum point, then I will replace the maximum point by my current number and then replace the index as well. If it's less than or equal to, then do nothing, right? So I'm gonna say if, let's say, P is greater than to make it safer, I'd better say points. Let me see. Yes, points I. Yeah, actually it does the same thing. It doesn't matter. Greater than maximum point. The maximum point equal to points I. And also mass dice equal to I. I'd better make I plus 1 again because I starts from 0 instead of start from 1. And finally, I'm gonna return a maximum point and maximum dice. Here we go. I can make 5, for example. So okay, I run 5 dices. Then how could this be possible? For so many things. Okay. Let me see if give me 1 second. Let me print it here. The maximum point is maximum point, and this is dice number maximum dice. Here we go. Okay, so I run 5 dices. The numbers are 5, 1, 1, 6, 4, and then it's gonna show you the wait, how come the maximum is -1 and this is dice number 5? Let me see. Wait, something's wrong. This is greater than maximum point. Shoot. Here we go. And then my dice is okay, here we go. Here I have 5 dices. The points are 2, 1, 6, 2, 6, and then it shows maximum point as 6. And this is dice number 3. Here, because we have 2 sixes, so it will always stop at the first one. Because why? Because here I said greater than, not greater than or equal to. If it's greater than or equal to, then sorry. If it's greater than or equal to, then it will always stop at the last number. And then we can run this, simply run it again. And this time, 6, 6 again. Let me try to run a time that there's no double here, only 1, 6. And you can see that maximum number is 6, and this is dice number 4. You can see it. Clear. So this is how I mean, it's a very simple. The only interesting thing is the random int here. Just okay. Let's go back to the thing. The same thing here. I just put a print. Let me see. Yeah, I just put a print here inside. I mean, this one's a bit better than the code in the slides, but basically the same. Okay, finally, we have a kind of like a very brief summary, which is the relationship. Module is smallest one, package, library, frame, work, they're everything like bigger. And in this class, oh wait, a minute. Here I also introduce something like self-built packages. But again, this will not be used in this class. This will be used a lot in software engineering. You will need to build a lot of packages. And as I mentioned, if you have some collaborators, everybody may build his or her own package. And here's a place how you can, build your Python package here. Make sure you have the initial function because that's required. For PyCharm, it will automatically build an initial for you, so you don't need to do anything. Here I'm not gonna show it, to save some time. I'm not gonna show it here, but I'm just gonna, include everything's included in the slides. If you're interested, you can read the slides by yourself. Or if you have questions, just let me know. And here are the things, but basically the same thing. You just, write a function in the initial and you define the things. And later, whenever other people try to include this package, you can write from something, include something, the same as what we just introduced. Okay, here we go. And finally, I want to introduce the PYPI. PYPI is short name for Python package indexing. So this is pypi.org. If you run Python a lot, you will really come here a lot because here are mostly all those kind of packages will be existing packages. And remember in class number 1, we mentioned that why do we need to use Python in data mining or in machine learning? The reason because there are so many great existing libraries. So we use, and where can you find these libraries? Here we go, PYPI. As an example, let me choose the NumPy. And later, in almost every project, you will see the NumPy. And here we go. We can see the newest version as updated about 2 months ago, and the version here. So click it. So for each such packages, 2 things are the most important thing. First is how to install it. You can just copy it, and this is the thing. And second thing is the documentation. Where's documentation? Documentation here. It is pretty long. You can read, but if you have time, really, I would highly recommend you to read some basic things. The sources, Striker, it has a lot of things here. Is it GitHub? Uh, yes, it's GitHub. That's another very long story anyway. But if you're interested, you can play with GitHub a lot. This is kind of like the open source, one of the best thing you can find on this planet. Anyway, and then the user guide, and then you can see many things. And to be honest, the easiest way for me is to directly ask Google instead of searching here. Trust me, because searching here, something is not that clear. You ask Google or ChatGPT nowadays is the fastest way. Okay, here we go. We're here. And then let's, as an example here, let's install the NumPy here. How to install NumPy? You just go to the PIPY, the very first page here, and you copy it. And here in the terminal, you will see the NumPy. Wait. Where's my terminal here? Give me 1 second. The new version terminal here. And then you just paste it. Remember, we just copied and you paste. Press enter, and then it's gonna be installed. That's it. It's just simple like this way. Later you will use the same thing to install some other is it done? Yes, it's done. And by the way, here, let me see settings, and I forgot where. PyCharm has already updated 2 new versions. Let me see here. Interpreter. Okay, here we go. And you can see here, packages, Python packaging tools not found, install Python tool. Okay, is it asked me to install the pillow or something? But anyway, I guess after everything you installed, you will see something here, which is the NumPy. NumPy should already be installed because here successfully installed NumPy. I don't know why here. Maybe because the ID the interpreter I introduced here is, I think, sure. Why invalid? I'm not sure. Looks like they have something new because I get confused because usually if you install it, it should have show the NumPy here. Anyway, I will try to figure it out. I will try to figure out in the next class. But basically, this is how you can install the Python. Sorry, install the NumPy. Now, since we've already installed the NumPy, we can just run like this way. Again, import NumPy as MP. Then you can have those kind of, those kind of arrays. Let's say I can have in my main function, I can have, let me delete everything here. Import NumPy as MP. And then I can have, oh no. That's weird. I did have already installed NumPy. Shows installed successfully. Why it doesn't? Why it doesn't? Must be because my PIP setting may be wrong. Let me do it again. Yeah, it's already it shows already there. I'm not sure. Looks like my PIP. Let me see. Hmm. And that shows error. I'm not sure what happens here. Python. The SDK. How come the invalid SDK? Anyway, I will show this example in the next class. I need to fix it because basically I need to search. That's something, PyCharm is a bit kind of like troublesome because it always have those kind of interpreter, Python interpreter issues. But let me see. Suppose suppose the installation is correct, then you can definitely run this thing. And then basically here's just to show you the NumPy dot array function, so it will be considered as an array instead of a list. So in this class, we will run 4 libraries very frequently. NumPy, it is for computing those kind of things. Pandas is something like Excel sheet. You can handle the data frame objects. Matplotlib is something for visualizing the data. And finally is scikit-learn. Scikit-learn is a library well for doing simple machine learning things. You can use scikit-learn. The great advantage is very simple and it's very fast. To do something more difficult, you can even use something like PyTorch or something. It is more general, especially for neural networks. You can use NN, a lot of things. But in this class, I'm not sure whether we will have time to introduce the neural networks, but fundamentally, we will just use scikit-learn to make it fast. So this is everything about lecture number 3. Regarding this issue, I will try to fix it before the next class. Then we can go to lecture number 4. By the way, here, lecture number 4 has already been uploaded. And here you can see I have 2 other documents. So this is the main document for the slides. This is extensive reading, as I know some of you are like PhD students or already got a PhD. If you want to have a more general, more extensive knowledge about the regression, about the mathematics especially, you can read this one. I believe here I showed a lot of things mathematically with some proofs. This was some courses I taught many years ago. It was a PhD level course. And this one is a CSV data, a CVS data set. So it's nothing but data. Yeah. And now I guess we can go to lecture number 4 here. So the data is of this way. So I've already shown it. So it's a CSV. Number 4 is the formal topic of the linear regression here. So first of all, I'm not sure how many of you have learned the basic, let's say, linear regression things, but I believe everybody has learned something like a linear function in high school, like y equal to ax plus b, something like this. So let's have a look at this example. Suppose I have these dots. What do you feel? You may feel it's kind of like a trend, like this way. So this is a linear trend. And here we assume this y is the response and this x are the attributes. Be careful here, x, because for plotting, at most we can plot only 3D, but here x is actually a p-dimensioned vector. I wrote like this way specifically specifically to emphasize that this p dimension. It's not only for 2D. This works for any dimensions technically. And we have a line here. But what if I want to ask you, hey, what is a specific line? I want you give me a very accurate expression of this line. How to do it? First of all, let's discuss which line shall we have. Again, use this example. I can have, here I plug 1, 2, 3, 4, 5. I have 5 lines here. I want to ask you which one is the best. What would you feel? I guess nobody's gonna say this yellow line, right? Otherwise, you probably need to see eye doctors. Then I'm gonna ask, so between among these, let's say the green one, blue one, red one, and the purple one, which one's the best? I guess most of you will say the red one is the best. But what if I ask you why? Why the red one is the best one? Or let me ask you why you want to eliminate this yellow one. I guess you will say, well, intuitively, red one is closer to these points. But what if I further ask you, what does closer really mean? You said closer, but let's say why the red one compared with, let's say the blue one, the green one, why the red one is closer, but why the green one is further? In other words, I'm asking you actually a metric, which means how would you calculate the distance? Because we need to define close and far, and hence we need to find out a way to define the distance, right? How to define it? Okay, so here is a method. For any specific line, it doesn't have to be this perfect line, okay? I mean, this red line, I just, use it for example. We define the distance as this one. So again, remember, here all the blue dots are what? Are the actual dots that we observed. These are the observed dots. And this red line is the line that I want to have. Now, suppose I know this red line is something like this. How can I define the distance? We can define distance as this way. So suppose this one, the coordinate is xi. Again, be careful. This xi doesn't have to be 2D. It doesn't have to be just one dimensional. It can be two dimensional. In other words, this 2D picture actually can represent for a p plus 1 dimensioned coordinate. The plus 1 means here. This x can be p dimensioned, and this y is 1 dimension. So the whole coordinate system can be p plus 1 dimensioned. Okay, suppose I have xi. Suppose there's a method I can find this red line called f. So this yi hat means what? Means nothing but let me see, how can I write? Yeah, mean this one. Oh, it is nothing but f xi, isn't it? Let me put a hat here. This means it's a vector. This is, suppose I already know f, okay? Then how can I get this yi hat? You just substitute this xi inside this f. Then I get this yi, right? Suppose I know f, okay? Okay, now let me reduce. Now I have this yi is again xi, yi are my actual observed data. And then I calculated my yi hat as well. Now I can define this distance. See it? Absolute value of yi minus yi hat. Or you can say yi hat minus y, it doesn't matter. And the absolute value, a minus b, b minus 1 the same, b minus a the same. And I can do the same thing for each of them. And hence we call this absolute yi minus y hat is absolute error, or you can just call it error. Suppose we've observed n data, which are x1 to xn, then we can define the least square linear regression, LSLR, to choose the line with the minimum or the least sum of squares of the errors. So you may say, why here I define here as the absolute error, but why you want to say the sum of squares of the error? This is because later we will try to get the minimum, to try to minimize this RSS function. But in optimization, it's very difficult to handle the absolute value. And hence we use the square of this. And the square and absolute value has one thing the same, which is a minus b squared equals to b minus a squared. You see what I mean? So it doesn't matter which one is in the beginning, which one is in the end, because we want to calculate the distance. So we change the absolute error to be the sum of squares of the error. And because I have n points, so I do summation all these n errors, all these n's square of the errors, and hence I have the sum of the square of the errors. Then again, go back to this picture. I have so many lines, six lines, five lines. Which line should I choose? Okay, I'm gonna choose the line such that this function is minimized. You see what I mean? And this is the mathematical principle of least square regression. Wait, how can I delete everything? Okay. Then in the next slides are some notations, the mathematical models. In general, again, suppose I've already observed in p-dimension the data. They are recorded as x1, x2, x3 until xn. Again, be careful because of p-dimension, so it does have p attributes. Okay, so let me give you an example. Let's say I observe n students. Students, they have the attribute 1, which is age. Attribute 2, which is, for example, let's say gender. Gender, let's say 0 means male, 1 means female. Attribute 3 means grade, for example. So you see what I mean? So let's say student 1, as which we just did in Python, we can say student 1, John. Let's say name is John, age, sorry, there's no name. Let's say age is 18, gender is 1 means male, and grade is 80. Student number 2, let's say age is 19, gender is 0, let's say Mary, then grade, let's say 100. You see what I mean? So that here I have p dimension the data. In my example, p means what? 3, which means age, gender, and grade. And I observe, let's say n students, I can have, let's say 20 students. So I have x1, x2, x3 until x20. Each student has p dimension or 3-dimensional data, which are age, gender, and grade. Okay, now we also have a response. Response can be something, let's say, good question. Response is what? Response, let's say, is the grade of another course. Let's say here, remember I said the third grade as, for example, let's say the grade of, let's say, calculus. And here I'm interested in the grade of linear algebra. I want to find their relationship. Basically, we may think that if a student is good in calculus, it's likely, very likely that the student would also be good in linear algebra, for example. So suppose here the responses are the grade of linear algebra. Let's say suppose it's 90, 91, 92, 90, 80, 70, whatever the numbers. So I want to figure out this F, which is beta 0 plus beta 1 x1 plus beta 2 x2 plus until beta p xp. Be careful, this x and this x are different. This x is just a notation. It's not the observed data x, okay? This x is a notation. Why? Because I want to figure out this line, right? And we call this line to be function y equal to fx. And because it's a line, we know lines must be what? Must be linear functions. Linear functions must be as the form of this one. And hence, you know what? The true parameters that I want to find out are here. Are this beta 0, beta 1, beta p. You see what I mean? So these are the things that I truly need to find. So for example, suppose I believe it's in the next slide. Give me 1 second. Let me see. Yeah, here we go. And for example, I have a y1 hat equals to the same betas, but I plug in the data of x1, means the first student. Okay, beta 0 plus beta 1, x11 plus beta 2, x12 plus blah, 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 plus beta p, x1p. Similar for student number 2, I can plug in the data x2. Be careful, all those bold things are the vectors. So that I have beta 0, again, beta 1, but here's x21, x22 until x2p. I can do the same thing until my last observation data, which is xn, and I do the thing. Again, be careful. my x as n, I'm sorry, my x as p dimension the data. In other words, my x has p dimension, p attributions, but I totally have n axis. It's gonna be something like this. Let me try to plot something. X11 blah 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 blah. X1 p. So here I totally have p dimensions. And then I can do dot 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 x n1 until x np. So here I totally have n observations. So at it, I have n observations. Each observation has p dimensions. So this is a basic structure. Okay, now for data I, what is my squared error? As we just mentioned, it's a yi minus y hat I, right? Be careful, again, yi is the true observation. We've already seen it. But what is a yi hat? We can just plug in the number here. So it is yi minus beta 0 plus beta 1 xi1 plus blah, 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 plus beta p xip square here. Okay, so this is the square error of the ith data, right? Then how many data we have? We total have n data, which is from y1 to y1 hat to yn hat. So what shall we do? Summation. Sum all of these n data square errors together, and here we go. So this is, let me. So this is one part for data I. This is for data I. And this is for all, which is nothing but a summation of all the I from I equal to 1 to I to n, because I have n observed data. Here we go. In other words, I need to let me use another color. In other words, I have this. And then be careful, what are not known, what are known. So all these xi's are already known, yi are already known. Why? Because the xi are known and the x or yi are also known. Why? Because remember, these are nothing but my observed xi's and my observed yi's. Remember the previous slide, which is here. I've already known these xi's. I already also known the observed my observed yi's. All these are already known. What I do not know is this line. I do not know. In mathematical language, what I do not know are this beta 0, beta 1 until beta p. This p plus 1 parameters. These are the things I do not know. And by definition, I said the least square linear regression is to find the parameters such that these are as minimized. In other words, what? I want to do this. I want to find the beta 0, beta 1, beta 2 to beta p such that this RSS, which is this function, is minimized. You see what I mean? And this is the meaning of this mathematical expression, which is again to find the beta hat vector and the beta 0, which is nothing but the beta 0, beta 1, beta 2 till beta p, such that RSS is minimized. In other words, here's the arg mean beta 0, minimize the whole thing. And this is the whole logic of the thing, how it can be minimized. Due to the time limit, I will introduce the solution and also how to use the Jupyter notebook to code it in the next lecture. Before I finish my lecture today, please make sure you do one thing, which is search Anaconda Navigator. Download, yes. Please download the Anaconda Navigator by yourself because it will take a long time. So, and the installation is extremely simple, just next, and done. That's it. So if you install everything, it's going to be like this way. And the installation will really take you some time. So I cannot, install it in my class. And then in the next lecture, I will try to introduce all the mathematical principles of the linear regression. And after it, we will introduce how to use Jupyter Notebook and how to use the Jupyter Notebook to do the very fundamental linear regression. And here we go. Here the Jupyter Notebook you launch, and it's gonna launch a browser page, which is a Jupyter Notebook. Where it is? Okay, here we go. So here's a I use Google Chrome, so it's by Google Chrome. If you use another browser, it's gonna be similar things. So this is a Jupyter notebook. Okay, that's everything about today's class. Thank you very much. Have a good night. Bye-bye.